without further ado, let's jump into this. This presentation, hopefully you're in the right room, is 20 mistakes that nearly killed projects and how to avoid them. So first off, why are you listening to me? Why should you care? Hello, I know several of you in the chat. For those that don't know me, my name is Matt Pollock. I work in the Solutions Engineering Group at NI, and that basically means I get to work on the biggest, most critical projects NI works on. And before that, I was in our support organization for about 12 years, 15 years total at NI. Over that time, I've worked with probably a few thousand different customer projects, many of which have gone very, very well, and many of which have either completely or nearly gone down in flames. And what I'm trying to show here is some of the most common things that I've seen that have nearly drowned these projects. The watch out for this, here's the gotchas that messed us up in the past, so that hopefully you can learn from my and my fellow customers' fails, because we've had many, many, many of them. All right. During this, I'll also be monitoring the chat, so please do let me know if there's anything that you want to chime in on. I am expecting and hoping that as we go, some of the esteemed colleagues I see in the room will have some other stories that you want to share, and I'm sure we could expand upon many of the bullet points or the slides I put up here. We could probably do entire presentations on single slides from this session. But my purpose is to give a survey of things I've seen that screw people up. But first, I do want to put in the Our Giants Are Female note here. I know she's been done several times before, but honestly, this still tickles me pink. Susan Kerr, this is the person who pioneered the graphical visual identity of the Mac. And I'm a longtime fan of Apple and Macs from before it was cool. When I was like 8 years old, I got to meet Woz, and I was the happiest person on the planet. Well, second happiest next to my dad, who thought it was the most amazing thing. Anyway, one thing that really impresses me about Susan is she managed to combine visual design and user experience to transform these complex technical solutions into something that was actually accessible. And for me, that very much resonates with what I need to do, because ultimately that's what we as engineers are trying to do. We're trying to take the ridiculously hard and Byzantine problems that we're asked to solve and come up with a clear and actionable way of solving them, and then expressing it in a way that computers can understand. Because it's a long time philosophy of mine that computers do precisely what we tell them to do. And almost every type of problem we're going to see in this presentation boils down to the fact that either you didn't know what you were asking, you asked it in the wrong way, or you just need to verify that what you said was what you think you said. So in all of this, the common theme is going to be failure. I know a lot of engineers are deathly afraid of failure. I see it as an old friend. If I don't make at least 100 mistakes a day, then I'm not really trying. 100 is probably too much, but it's a good day when I can find myself making a new mistake. Those are the days that we learn something. Those are the days that I find something that's going to help me out later. As part of this, hopefully you'll find that out of the 20 or so things that I show, most of this audience probably knows 18 or 19 of them or has experienced them themselves. I'm hoping that that 19th or 20th one that maybe you hadn't heard, or the small detail of what caused us to look for this problem in the first place, may give you that insight for your next project. That's what I'm hoping for. First off, I don't do any presentations without talking about one of my favorites, source code control. I know this is the GLA Summit. I know all of you are already doing source control very well. I know that you never make mistakes. Yeah. It actually blows my mind how many projects I see that have CLD and CLA level people on it where we are still not doing source control right. And specifically, I mean this. Never ever do this. If I see anybody in this particular session sending around zip files like this through their email because it's quicker, you should be ashamed. I say this because I had to do this myself a couple of weeks ago. And this is usually a symptom that you haven't invested enough time on a package management system, proper package builds, proper deployment mechanisms. If a yes, it is a good slide, Benji. Thank you. If you see yourself doing this, it usually means you need to invest more in those areas. And even though it might be too late for this project, you better get that in order for your next one, because this problem doesn't stop. Another thing that I see in almost every large LabVIEW project is problems with using source control. So not just that we're using it, but we also need to use it well and structure our systems and our code so that we're doing it in the right way. Has, just by a show of boos in the chat, who's had this problem? Just say boo in the chat if this has happened to you. Hey, we see a few. I have spent my last 2 weeks basically fighting merge battles, mostly with myself and my poor decision making from earlier on in these projects. And whoever typed booze, thanks, Phil. Very nice. It is a 5 o'clock session in Austin, so cheers. I find myself having to deal with a lot of problems like this. These merge battles will get us if we aren't careful and if we don't nip it in the bud early. If you wait too long to take care of this stuff, it's just going to get worse. And really, your only hope at that point is either your project ends and you can walk away, or your end customer is really happy to pay you lots of time and materials to refactor code and get no additional benefit. If you find a customer like that, please let me know and send them my way. I'd love to talk to them. So I give a whole presentation on how to avoid merge battles with LabVIEW. I steal some of the content here because it's valuable. The biggest one is you're going to get merge battles if you have multiple simultaneous edits to the same file. So what we want to do first, make sure we're not all working on the same file. Many of you have seen this disgusting pile of spaghetti before, but I always like putting it up here just so I can feel slightly better about my own coding. Mine looks only marginally less bad as this. As part of prep for this session, I actually looked at old code of mine from 2005, and it was shameful. And yes, they did use clusters. It is in itself a cluster. Annoyingly, that is the most famous piece of G. Yes, unfortunately it is. But I don't really want my G code to be famous. I want my front panel to be famous on the awesome system that it's running, not someone showing me a diagram. So this is more what I'm looking for. Actually, this would probably fail a code review from me right now because it's got too many constants sitting on the diagram. Those probably need to get pulled out to a config file. That's okay. Point is, delegate the responsibilities down into individual modules that can run independently, and more important, the developers on the project can edit them and own them separately and make changes to one without having to resave every single thing else. Usually, if you're starting with this, you're already doomed. If you're just piling on to a big VI, you're doomed. If you can take even an hour and whiteboard out some modules, it's a lot better to start with. Was there any unbundled by name? Yeah, right over here. So they mixed, it's all good. Why have consistency when you can do it this way? All right, so this is better. Other things that I want to get to as we talk, I get a lot of questions about frameworks. Should I use a framework? Should I make my own? Which one should I use? This is when we start getting into the meat of the decisions that we need to make on a project that's ultimately going to determine how hard it is for that project to succeed. I've seen customers who saw a cool presentation on Actor Framework and decided that Actor Framework was therefore the solution to every technical problem posed to them. Actor Framework is never overkill, Sam. It doesn't have to be. So you can be successful with just about any of these frameworks. The thing that I see failures come from are these second bullet points. You got to consider not just you, the architect, who's trying to pick the thing that is the most beautiful solution, is the most pleasing, is the one that makes the most sense to you, or would be the easiest for you to implement. Because odds are pretty good you're not the only one implementing. You need to consider the developers that are going to maintain it and build it with you, as well as a customer that would need to use it and possibly own it once you deliver it to them. That shiny architecture may well be overkill if the person who has to own it has rudimentary knowledge. And while it is absolutely true that we can and should teach other developers and our users how to work in the right paradigms, they may not always have time, or they may not have the interest to do that. I see this in many cases where we've had to come in and save projects where an awesome developer built something and then they left, and then the people that were left holding the bag didn't know what to do with it. That is a failure of the architect, and it's a bad one. Another one that I see a lot on the flip side of that is that the scope of the technical challenge you're trying to solve may require more than just that quick duct tape together proof of concept with a single loop and a local variable on it that just keeps getting glommed upon in a spiral fashion, going all the way down into the toilet. Yes, Sam, I agree. Throw away the prototype. And for me, I actually throw away the prototype and the next prototype. It's usually the third one that worked. QMonty Python sketch for the fourth one, lad, that one stayed up. Yeah, that's what I'm going for here. But those two things of someone inheriting somebody else's code that was incomprehensible, and the flip side of code that just fell over or under the weight of everything that it was being asked to do but was never designed to handle, that's really the crux of a lot of this. Now, I don't want to get super deep down into weeds, but I would be happy to if there's interest of exactly the nitty-gritty details of what works and what doesn't here. My statement is, don't reinvent the wheel, and use something that's approximately the correct size hammer for the nail that you're trying to handle. And consider very, very carefully before writing another QMH, queued message handler, like Active Framework or DQMH, or another sequencer. I have seen far too many people waste months on attempting to build TestStand because they said at the beginning of the project, TestStand is overkill, we don't need all that, we're just going to run through a list of stuff and get pass-fail. And then we need reporting. And then we need conditional branching. And then we need to do X, then we need to do Y, then we need to do Z. Oh, by the way, we need to have that be a human editable file. Actually, we need an editor for the file so they don't have mistakes. Guess what, geniuses? You just built TestStand and you wasted 6 months of time when you could have just bought it. And yep, good point in the chat. Same deal goes with reinventing not just frameworks, but also reuse libraries, and indeed reuse libraries that may exist in other languages. You don't need to rewrite a driver if you can just call the DLL. You don't need to reinvent the most amazing string parsing library in LabVIEW if you can invoke some Python code. There's no need to do things the hard way, but we as architects very often get that not invented here problem, where we see a really cool problem, we really want to solve it, even though there's already a solution and we could have just moved on with our lives. I'm just as guilty as the next person on this, and every single time in a after action review or a retrospective on a project, we look back and try and find, all right, what did we build that we didn't need to? What were the false paths that we took? Frequently, this is one of them. Either we tried to go too shiny or not shiny enough, and we kind of knew it at the beginning too. You should never have clear requirements that demand extensibility and modularity and then not go with a framework to help you. There's almost always something, even if it's not the whole thing, something that will get you at least part of the way there. And many of them are very well architected and impose minimal requirements on the rest of your design to do that. This one, Datacom. I have done numerous presentations on just this topic because it's something we fail to think about properly when we're designing the system. Really, the Datacom needs in a data flow language are what determine the architecture. This is what are going to give us the baseline requirements of what pipes we need to lay down, what the connections are between them, how flexible those pipes must be, and how the data needs to switch between them. Example. Classic example from this audience, global variables. Generally a bad idea. Piles of local variables, generally a bad idea. Also a bad idea is trying to shoehorn message data, example, shut down or reconfigure, into things that aren't designed for reliable transport. Message data being sent over UDP or via a shared variable or via a lossy queue, watch out. Data, similarly, that's a stream that's meant to be, say, a high-speed RF streaming application or an ADAS recording system where you're pulling in data from potentially dozens of different sensors. You better have a lossless communication mechanism. You better also have a zero copy mechanism such that you're not just wasting all of your time duplicating your data around. So I'm a big fan of DVRs when appropriate. And one of my favorites happen to be external DVRs, also known as eDVRs. If you're ever getting data from an FPGA, like big bulk data that's really fast streaming into your system, example, if you're reading in from a 4K camera, or if you are reading in from a high-speed LVDS stream, or you're reading in from a reconfigurable RF card, the only way I would ever want somebody to play with that data is by grabbing a data reference and working on that, because that allows zero copy. Similarly, if you're going to be logging that data, you better be using the TDMS Advanced API, which lets you wire in the eDVR directly, meaning zero copy all the way to the disk. Yes, there's a copy on the driver layer, but still. That has been some of the types of bottlenecks that I've seen take down projects where the datacoms that were chosen work really well for the proof of concept. And they forgot to scale it. They forgot to scale it to either the number of nodes in the system, the number of independent threads that needed to run, the number of instruments you're reading from, number of channels on those, etc. If you don't test your pipes to make sure that they can hold the full pressure of what you're trying to put through them, odds are pretty darn good they're going to burst on you. And they're probably going to burst late in your project when you're at the customer site with the real equipment, when it's going to be really embarrassing to have that spray on your face. I've had dozens, if not hundreds of times when I've had customers call up and be in a situation where they're trying to just push too much through either the wrong type of pipe or they don't have enough kinds. I could go for hours on this particular topic, but take some time to understand at the beginning of the project what the data streams are in your system. There's probably going to be more than one. Understand the quality of service needed for them. Is it lossy? Is it lossless? How much data do we have? What happens if I miss data? Is that critical for the system or do I not care? Who needs to get this data? Is it going to be broadcast out to an unknown number of recipients, or is it just going direct point-to-point FPGA to processing VI with an in-place element structure to a TDMS file? Architecture is going to look very different depending on that. I also recommend scoping the data as tightly as you can. If I ever see a customer that does this again, I'm going to scream. So what this is the navigation window. I chose to do it this way to give you an idea of how much crap was on this front panel. But I want to draw your attention over to here, to this guy. This is an array of clusters, of arrays of clusters, of arrays of clusters, of arrays of clusters, of arrays of clusters, of type defs of clusters. All told, I think this VI carries, how many elements? There was somewhere upwards of 5,000 different items in that type def. And yes, they used the type def, but they failed to separate out their data. They failed to encapsulate anything. it was quote unquote easy to debug because all the information from the system was right up there. But attempting to do anything in the system, unfortunately, they were passing around the giant cluster of doom to everything. They're making data copies everywhere. And worse, the data was completely unprotected. I got called in on this one when the customer was complaining that sometimes randomly data was getting corrupted. Well, you can probably guess data wasn't actually getting corrupted, but they had instead failed to notice that one of the places that modifies this data was modifying what it shouldn't be doing. And yes, they did store this cluster of doom in a global. Please don't do that. Yes, yikes. It took us quite a while to untangle this one, and ultimately the correct answer for how to salvage this project was to do it again, because refactoring this would have taken twice as long as actually just scrapping it, using this as the prototype, and taking lessons learned. Ultimately, the customer did not choose to do that. They chose to limp along with it and institute some much stricter review and process when designing their next project, which I understand the business decision. It makes sense. As an engineer, I would be so pissed off if I had to continue working with this, even though we knew it was just doom. And before anybody mentions it, no. Don't just wrap the type def in a class and say, voila, problem solved. No, now you have a class of doom and then your problem is harder. I see this as well, where we have a single class that contains, through composition, every other piece of the system inside of it. No, this is exactly the same problem as this. It's just one level obfuscated, and it makes it look like you are a little bit more sophisticated. And I see a comment in the chat from Kevin, teach the analyzer with depths of structures. Yes, that's a good approach of making sure that you don't have too much complexity in one spot. That makes good sense. And generally, when I'm looking at code, if I see the giant cluster of doom or the class of doom, that tells me immediately that whoever wrote this code hasn't taken the time to structure their thoughts properly and figure out what it is they're asking the system to do. If you can't tell the computer what to do properly, it's going to do whatever it thinks you meant. And the more confused that thought process is on your end, the more confused the expression of it is in your code, the more bugs, the more stupid errors, the more interminable project delays, the more angry emails from your customer you're going to get. So while we don't need to spend a big upfront development time to try and architect and plot out everything, we at least need to try and get it into channels, get into buckets, get it into smaller components that we can more easily work with. We'd all love to have 6 months of design and requirements gathering before we start with a project. That never happens. So we have to do the best with what we can. If you have this, you didn't do it well enough. All right. Another one that gets my gourd a lot is reuse libraries. We talk a lot about reuse libraries. We advocate for them. We say to customers who are having trouble, they're being inefficient on their development, customer, you need a reuse library. That's going to make you much more efficient with what you're doing because you only have to write it once and then you don't have to touch it again. Well, in practice, I don't know how many of you have seen this particular problem, but I've seen it a lot. The reuse libraries are great in theory, but rarely are they actually designed properly to be reused effectively. So you might be thinking, hey, it's great, I can just take this, it's no problem. That type def doesn't have exactly what I want to need to change it. Oh, I broke that, then I need to swap this out. My customer said I need to replace the UI. Oh, I can't use that TDMS logging format anymore, or it uses a different trace tool than I like. Ooh, we have to rewrite all the test code for it. Yeah, we get trouble at that point. And especially those last two, if you're trying to use a reuse library, but you're trying to use it for something it wasn't designed for, you tend to find lots of exciting features. And it also tends to be a problem that changing it to adapt to your needs really doesn't work, because then you break other people. This one's a pretty thorny problem to solve, but for me, this is what gets us past it. And that's to have some kind of a contract in place. And by this, I mean the libraries that are meant for reuse need to have a very clear, well-defined purpose and scope. They do this and nothing else. If you want to do something else, you're using something different. Ownership and a maintainer. A reuse library is not the network share where you dump all your code from your previous projects and then it just sits there to die. The reuse library is a garden. It needs to be tended. It needs to be weeded. It will break if you just leave it alone. You need a process to upstream the changes. If you find a bug, but you have no way to fix it or to get that out to other people, what kind of value are you really getting out of it? Documentation. I don't know about you all, but I've inherited worthless code many times. And even some of the great code that I've inherited doesn't really tell me the assumptions or the limits of what it was designed for. And I'm going to touch on this again as we go through, but I am a humongous proponent of not allowing anything on my system that doesn't have a version associated with it and a package that can get it on there. And along with that, functioning tests with sufficient coverage so I could actually upstream something to it and tell if I broke anything. None of this is cheap. None of this is easy, but these are the hidden costs of the reuse libraries that tend to get swept under the rug. We often are going to advocate for reuse libraries as customers and say, you should just start reusing things. That tends to fall over pretty fast unless you put some process around it to at least put it on some rails. And just curious, for those of you in the chat, have you found that you would agree with this strategy? Or are there things that I'm missing here? I ask because I get asked this question a lot, and this is my stock answer. If there's other things that we need to be considering, this is a great point in time just to shout out and tell me what I'm completely overlooking. And a comment from Kevin, functioning tests can get difficult. Most definitely it can. And I'll touch on this a little bit when we get to some more testing pieces later, but if you aren't able to test without, say, a $500,000 STS system, then we don't have sufficient abstraction in there to get enough value out of things. And Alejandro, I like your famous last words. Project implementation be quick, since I'll just reuse what I did last time. Yeah, I have been guilty of saying precisely that more than once. And every time I find myself saying that now, I bite my tongue and add 50% to my estimate immediately. Because failure to do that has cost me a lot of embarrassment. And most of that cost has come in that I failed to account for needing to validate that what I did last time would actually still work this time. All right, let's get into some little nitty-gritty bits that have burned me in the past. Most of you probably already know about the option to separate compiled code from source. So VIs in earlier versions were both the source code and the compiled object code in the same binary file. We gave the option many years ago to separate those out, such that the VI is just the source and the compiled code goes in a compiled object cache, sitting off in a magical, mystical, hidden location on your disk. It's great for minimizing the bogus source control changes. Example, if you relink something, you don't have 200 VIs that need to get changed. If you switch from RT to Windows, you don't get everything saying it needs to be resaved. But that works great so long as you don't try to deploy any of your source code without going through a build process first. Because if you just try and say, cool, I'll pull down the latest code from my repository on my test stand system and just run it. The problem with that is that on the system you just pulled it down on, it won't have the compiled code. It will break. I see this very, very frequently with test stand customers when they're trying to publish code, that it doesn't work in the Lavi runtime adapter. And this is one of the most common problems. And just as a side note, if you use the project option There's an option within the LabVIEW project in the properties of the project itself to mark your items in the project to have compiled code or not. Take a look at that one, because very often what I find, if someone has that particular issue where it works in dev but not in runtime, there might be a file sitting in there that maybe some rogue developer had the wrong option on their dev machine and committed code with the wrong option. I actually had a project go for a week-long escalation where a production line was about to get halted because we couldn't solve this thing. The end culprit was a CTL file that didn't have the correct option marked. So we had deployed a control file that wasn't compiled, and that actually killed it. So beware of that one. What I'd recommend instead is first really look into using packed project libraries. This is basically their use case, is for this exact thing of carrying around reusable code that's already precompiled, so it's, quote, has all the issues sorted out. That's not exactly reality, but that's the intention. Or do a source distribution where you're very careful to get that setting marked properly. And just as a side note as well, that compiled object cache, it lives in the user data in Windows, which means that if you open the project in the development environment and save, actually you don't have to save it, you just open the development environment and close it, it'll suddenly start working on that system. It's a great Heisenbug. But maybe if that system's logged into the production account, it still doesn't work. It's because the compiled object cache actually gets a different instance per logged in user. So just something to be aware of. That was a surprise when we had to go dive deep into that rabbit hole for that particular issue. And 2 comments in the chat. First, from Kevin, I saw clearing caches before you do a build. Yeah, that helps you reproduce that you have everything proper on the build system and that you aren't getting lucky by having a build system that just happens to have seen that code before. Absolutely. And also a question from Amit. Oh, hi, Amit. Does packed project library work well with source control? It can, depending on how you have it set up. So typically for me, my packed project libraries aren't in my source control. I have the source for my packed project library, and the output of my source is a build spec for a package. And then I have on my anything that's actually going to use that PPL, it has as a dependency to install that package. So I never want to have the situation where I have a caller of what's going to be in a PPL calling directly into the VI files outside of the PPL. You are begging for cross-linking and loading issues if you do that. Watch out. And what I found, even though it's more tedious to set up, is to get the build process in place to have tiered builds. You build the subcomponent, the component, then the caller. That's how you resolve those. And it takes a decent amount of upfront infrastructure to do it right. But that's been the solution to that problem from the times I've seen this come up. And thanks for the reference, Thomas, on the compiled object cache. And by the way, clearing the compiled object cache is also one of the, quote, magic fixes, along with Control-Shift, click the run arrow to force recompile everything. That's how you tend to clear those things. Sam, was that for me or for the general chat? Sam's asking, do I ever use things like make or scons? For me, I tend not to use make directly because I'm kind of tied into NI's build infrastructure. We have wrappers around make as part of our build infrastructure, as well as scripts that we run in our pipelines. So we use things like make, but we don't use it directly. All right. So speaking of which, dependencies. If you have these statements, you often have a dependency problem. So this is especially if the problem changes and its very nature from machine to machine, you probably don't have a consistent environment. And that's really, really going to cause you trouble on this application that's deployed in multiple places, especially as we get multiple versions and multiple updates installed. If you don't have consistent and coherent update packages for everything, you can very easily find yourself in dependency hell. And this could be as simple as something like a different version of a LabVIEW driver. This could be the example file that somebody had edited on their development machine wasn't edited on the deployment machine. It could be that the interface to a library on VIPM changed, or that someone has an older version of it and that function had a bug. These things happen all the time. So the mantra I keep stating is that you need a consistent versioned set of dependent software, and you need to have a way to be able to quickly get a list of all the versions that are installed. That's my first one of my first asks of troubleshooting of a system is show me your installed package list, and then of course send me your trace and error logs so I can see what happened. The key thing I like to note here is you're not allowed to have any random crap in userlib or modified example code or anything else that gets put on the system without an installer. If you ever take that zip file from the source control slide and drag something into a National Instruments directory, for shame. You are asking for problems. Everything should be in the project folder of your project in source control or an installed dependency, and you can find those dependencies in the source control folder. Ideally with something like VIPC files or a feed to subscribe to get those files in, however you do it. And for me, the code smell here is if you find yourself writing the wiki page or the README file with a list of installers and packages, you can probably do better. And if that list of things you need to install includes things that don't end in exe or .vipc or VIP or NPKG, you got problems. If you're pulling random VIs off of random locations on your network drive, stop. You're just digging your hole deeper. You need to get out of there. You need to fix this. And yes, Sam, agree. You could at least script it or do a batch installer. Ideally, it should take a new developer who has no idea about your project and who has managed to correctly navigate source control to get it down on their system. It should take them no more than 4 clicks to get all the dependencies they need on your system. That's the ideal. Granted, we always run out of time and we forget, but we should at least remember that and shoot for it. I'm not saying that you have to be perfect. I'm saying you should feel at least slightly ashamed that you're not doing better. Because I am exactly guilty of this. I wrote that last bullet point because I wrote that wiki page last week. Shame. And Michael asks, is there a way to list all VIPM packages installed without VIPM Pro? Well, at minimum, you can open up VIPM and show installed packages. That's usually what I do. And Sam says print screen. Yes, exactly. That's one way. I would also question if you have a detailed enough dependency hierarchy and you need that feature, that is why VIPM Pro exists. Consider paying for it. Consider charging it as part of your project cost to a customer. I know it's not the greatest of answers, but I'm also very glad that we have VIPM, and I want to make sure JKI can keep developing it. They can only do that if they get paid. And yes, I'm a humongous fan of setting up continuous integration systems to do this work for me. Hey, look, let's talk builds. So countless numbers of projects, all the time is spent on the source code. All the time, if they do testing, is compressed at the end to test the source code. And then it's time to ship. And oh no, it doesn't build. You have failed. You should be building this thing as frequently as you can, as early as you can, to catch these issues as they're introduced. You really, really need to be doing this. Even if it's just as simple as setting up a quick little Jenkins instance that finds every LabVIEW project file in your repo and calls the build specifications under my computer. You can write that script once and never have to rewrite it again and use it for every single project you've got. That'll at least tell you that you broke something. Similarly, if I wait until I've made 200 or 3,000 commits to source control before I find that something doesn't link properly or load properly in the build, that's a very big haystack to dig through. I like small haystacks. Try and get this done as early as you can. The ideal here is a continuous integration system because then you don't have to think about it. All right. Anybody ever have problems with this, where something happened on a system, but you don't know where it happened? Oops, the system doesn't work. Yikes. This, even architects, I see having this kind of problem a lot. My advice here is, at minimum, isn't that the default? They'll have a error message. No. So at minimum here, at least make it so that your system can tell you that a problem happened and where it happened, and that you never miss any. And that could be as simple and a very easy application of actually wiring your error wire. And yes, you should be turning off automatic error handling. You need to take care of that yourself. But the deal here is, as soon as you start having multiple threads, multiple actors, multiple modules that make up part of a larger system, you need a way to propagate those errors through and bubble them up to the point where you can detect them. Otherwise, you're going to be piling upon work and getting an exponentially tougher problem to solve later. I want to pause a sec. Amit, you asked a question. You're working a lot with FPGA. Any consideration with number of controls on the FPGA panel or complexity up there? So you've correctly identified a loophole on the try not to put too much stuff on your front panel. I'd claim that for an FPGA, if you have lots of tag-based data, so telemetry information, single point, lossy data, you could put that on the front panel. At some point, you may be putting so much stuff on that front panel that if you're trying to read all those front panel items frequently, you would have been better served by putting that into more of a stream or a message architecture where you're piping it up through a DMA channel. That's a judgment call, and you really just have to know how you intend to use the data. And in the comments, are there good loggers? Tons. I've got a couple that I like, and actually I'm going to mention some in a second here. And there's some really good open source ones as well. So Sam and Jorg, you're doing that right. And my thing at the end here, don't force developers to do it right. It should do it right by default. They should have to actively try to break it for the error not to get through. Now, the usual way I say that is, you're building a framework and you're having developers make VIs. Anything that shows up on error out terminal of the VI, even if they don't know how it works in terms of the framework, that needs to propagate and get bubbled up to where it can be seen. That's an architectural problem. It's one you have to solve. Otherwise, you are building a time bomb. Same thing with tracing. If you've got a deployed system, you don't get to use probes. You get the customer calling you up and saying, hey, it didn't work last night. Fix it. And if you are taking that moment to start asking, maybe I should add some tracing to my system and figure out what happened, you're in for some serious pain. You need to have those breadcrumbs put in place when you're first building it. And usually what I like to do here is to have the same logging framework for errors and events and set a priority or a severity level for it, and use filtering on the back end of my log files for it. Now, frequently this takes the form of me setting a flag in my system configuration file for what level of severity I want logged. And that can range from critical to error, warning, informational, and debug. Usually I keep it at warning or error level, but if I need to see what's going on in the system, I'll flip that switch, run it again, and hopefully get a big pile of data with timestamps and events on it. You could use desktop execution trace. If you're on an RT system, all of our RT systems have syslog-ng built in. You don't need to build another logging framework for RT targets. It's already there. We also have a library function with VILib that lets you write to the system log. I don't really like it that much because it doesn't give me the options I want, but it is there and it functions pretty well. And if you really need to get down into the weeds, you can also use execution traits for Windows. Basically, Windows level messages for debug breadcrumbs. And that I find useful if you're trying to harmonize event data across both your LabVIEW and non-LabVIEW code that's running simultaneously, because they can both call into that common library. Pause. All right. Testing. This is an entire presentation. You need to be doing your testing, and you need to be optimizing so you can find the code to blame as quickly and efficiently as possible. This could probably be a week-long course on how to do this properly. But for me, if you're following that goal for your unit testing and that's your mantra, you'll get the right idea. You'll get to the right end place with it. There's always more unit tests we can write. There's always more coverage that we should be getting. At some point, we have to ship. So there's always that tension. But unless you write perfect code, you need to take some time up front to at least limit the size of your haystack and make that needle more obvious to find. If I can get it down to the module level from my tracing, great. If I can get it down to the VI level from that as well, perfect. Then I can go back to my unit testing and see, all right, what did I miss here? And there's probably a test case I didn't think of or an outlier that just didn't come to mind. Same thing with stress testing the system. Push it to its limits before your customer does. Otherwise, you're going to be in for a world of hurt. Again, this is a whole session, but there's a ton of things that have come up. I got 10 minutes left. I want to do a quick bit of greatest hits of stupid code errors that have caused inordinate amounts of pain. Anybody ever use the typecast function? If you do, stop. This thing is basically a crash waiting to happen because it just reinterprets the bits differently. It has no protections whatsoever. And if you use a typecast function, LabVIEW will crash on you if you attempt to access things incorrectly. This is a severely boiled down version of the root cause of an issue that took us a month to figure out. Basically, we had DVRs and then an untrustworthy communication function that basically they had multiple different types of DVRs going into this communication layer, and it wasn't properly guaranteed that the one they got out was the one they thought it was. If you attempt to typecast something into the wrong DVR type and access it, you crash, and you crash hard. And question of what would you use instead? Flatten a string? Yes. Generally speaking, people reach for typecast because it is super fast. The reason it is super fast is because it provides you no safeties whatsoever. Consider this very carefully before you reach for this function. In most cases, you can accept the hit of serialization, deserialization. And if not, then you need to have ironclad testing that your pipes are exactly what you think they are and that you don't get those crossed. And if we're doing just doubles to ints or doing different typecasts, the key here is going from a binary string into a representation that then gets indexed. So it's a similar thing as you attempt to take a random binary string, cast it as an array, and then index or access an element in the array. Congratulations, you just have a memory exception. Boom. Other one, classic, and yet I still see this on my projects occasionally, failing to have the shift register, meaning you get a bogus reference, meaning the important stuff fails. Happens a lot and is usually very annoying because you start troubleshooting this for the problem, not this, because this is what your error reporting is saying is the problem. Oops again. I've done this exact thing about 2 weeks ago, and I just wanted to kick myself. 2 arrays, 2 different data sources. You better be having a quick assertion test in here that these arrays are the same size. Otherwise, you're going to truncate off the extra elements on whichever one was larger, and it'll only execute the number of times as the smaller one. We were incorrectly assuming that everything was fine because we were seeing exactly what we were supposed to see over here, but we failed to check that one of these was too big. And we were wondering how come the data streams became out of sync later. And we thought we had garbage data coming from one of them is basically what happened. Admit this one might also go back to your earlier question. I've seen this before. And a couple of things to note here. First, yay, it's a stack sequence structure. Second, there's 15 pages in here. Third, it goes down for about 2 more monitors that way. And guess what they do? They packaged, first they declared their variables here. That's what this was, because this was a C programmer. To all of these via property nodes in the second half of these frames. That's going on this wire. This is the set of references to every single thing on the front panel, which then gets passed into sub-VIs. The way that they access data in the system is by using front panel property nodes of the giant monolithic VI at the top. And everything in multiple parallel executions are all reaching into the front panel. And you know what's my favorite part about this example? They had a style guide. Their style guide said to do it this way. And they religiously followed it for 5 years to build this application. They called me 5 years later when the performance was really slow because they didn't test the worst case throughput of the system until the end. I had some very bad news for them at that point. And yeah, who wrote the style guide? Someone who made a mistake. And amusingly, it was, of course, somebody who left that company 5 years earlier. So they wrote it down. They did a proof of concept. They wrote a style guide. Hey, do it this way. And then they left. And 5 years later of development, they got to the point where buying faster PXI controllers just couldn't cut it anymore. Because that was their solution. They just bought a better controller every year, and it was enough. And yes, Peter, exactly. LabVIEW just isn't as fast as other languages. And to their credit, they did have the labels on here. I removed them to remove identifying information about who this was. But this one still haunts my nightmares. Other one, DQMH. If you got a producer that's pushing really fast messages, lots and lots of messages into a receiver module, and then you're doing processing on it and displaying it, watch out. I ran into this from my own stupidity for not doing a stress test. Everything was working fine until I ran it overnight before we demoed to the customer. Memory usage went up by 80 gigs. And fortunately, I was on a system that had 100 gigs of RAM on it, but that's not usually a great solution. End result, I needed to have a helper loop with a lossy queue. The queue from the UI message receiver to the DQMH message handler is lossless, meaning unbounded size, meaning memory leak if you aren't careful to match the rates of this and this. Serious problem on my side, and I didn't catch it until way too late in that development. Be careful. Easy fix, but be aware of it. And yes, that's not a leak, that's a growth. True, until I run out of RAM, and then it's an explosion. Other one, timeouts. Super simplified version. We had a big hill system that was pushing data over 10 gigabit Ethernet into an FPGA. That FPGA acts like an internal router, splits over peer-to-peer to a couple of other FPGA cards, which then talk to the DUTs. Worked fine, except it reset itself once a minute. Well, crud. This needed to go to production in 3 days. Root cause, FPGA. We were being good citizens and numbering or putting unique IDs on the packets we sent over to the downstream nodes to make sure we didn't miss anything. Unfortunately, our source for the packet ID was the iteration terminal in a while loop on an FPGA. They run fast. Maximum value, which hits in about 53.69 seconds. Once a minute, these guys thought that they were no longer receiving any data because the packet ID was no longer incrementing. Oops. Worked great on a quick test case. Unit test worked fine, and it was good there. I'll end it here because I incorrectly thought I had an hour. I actually had 50 minutes. Thank you, admins. Hopefully there's a few things on here that were useful for you. If nothing else, just some nice catharsis of, yes, I've seen that. I'm not the only one who's made that particular mistake. I'll be posting the slides up shortly. There's a couple of cases at the end I didn't get to, but they may make for some amusing reading. All the best hits were in there already. And if you want to hang out after the session in the breakout room, please do. Happy to commiserate over various failures with you. Thank you for coming. And just shout out, in 2 hours, Norm and I are doing a silly love of barbecue style joke fest. Please come. It's going to be silly. You may wish to bring a beverage.